on the line with us. So with that, again, I'd like to welcome you, and I will turn you over now to Joe Steckley with EPRI. Joe, take it away.
Great. Thanks, Kathy, and welcome to everyone. And thanks for joining us. This is our third and final webinar in the Hydrogen Hub series. The first two webinars that we held over the last few months here have covered feedstocks, hydrogen feedstocks, and transportation and storage. If you missed either one of those, there will be an email to all the registrants of this meeting that comes out after the meeting that will link to not only this recording, but those prior two recordings as well. I want to thank all of our speakers that have joined us along this series, as well as our speakers that I'm about to introduce here. And I want to give a special thanks to the Hydrogen Forward team, especially Jeff Bechtel and Lexi Ryan, for their partnership with us at EPRI over the course of this series, and we look forward to continuing to partner with them in the future. With that, I'm going to introduce each one of our speakers here individually and give them a couple of minutes to introduce themselves. So with that, I will start with Linda Dempsey, who is the Vice President of Public Affairs at CF Industries. And Linda, if you want to go ahead and give us a couple of minutes talking about you and your organization.
Thanks so much, Joe. Good day, everybody. Hope everyone is well. So I'm the Vice President of Public Affairs for CF. CF is based in Deerfield, Illinois, just outside Chicago, and we are the world's largest producer of ammonia, also a major hydrogen producer, and we have 9 manufacturing complexes in the United States, Canada, and the United Kingdom. Ammonia is a molecule made of 1 part nitrogen and 3 parts hydrogen that is produced through the century-old Haber-Bosch process. And for more than 75 years, CF has been very focused on the nitrogen part of that molecule because it is critical to plant growth and increasing crop yields. And indeed, most of our production and the world's production of ammonia today is used directly as a fertilizer or upgraded into other forms of nitrogen fertilizer that make possible about 50% of the world's food production, enabling billions of lives and higher crop yields, and also preventing unnecessary deforestation. Ammonia is also used for other purposes, including to reduce NOx emissions, such as in diesel exhaust fluid. But given its significant hydrogen content, ammonia is increasingly being looked at for other opportunities, particularly if we can decarbonize it. And so CF, we are fully committed to decarbonizing our production. We've announced a target by 2050 with an interim goal of reducing our carbon intensity by 25% by 2030. And we are working with partners and others to decarbonize across our broader supply and distribution chain as well. And so I'm excited to join with EPRI and Hydrogen Forward and our colleagues today to talk about some of the ways that we can work together to expand these opportunities, because the decarbonization of hydrogen, ammonia, and its potential uses in a whole bunch of different areas, obviously as a fertilizer today, but also as a potential clean burning fuel or as a hydrogen storage and transport mechanism, really presents some strong opportunities to accelerate the clean energy economy. I'll turn it back to you.
Great, Linda. Thanks, and look forward to talking to you more about ammonia and decarbonization of that feedstock here soon. Next up, we have Gil Castillo, who is the Senior Group Manager of Product Strategy and Regulatory Compliance at Hyundai. Gil, if you want to go ahead and introduce yourself.
Certainly. Thanks for the introduction, and thank you everyone for joining us. So I've worked in the auto industry for about 30 years or so, and the last 11 years have been with Hyundai Motor America, which is the sales arm of Hyundai. When I first started out at Hyundai, my primary focus was really working on advanced vehicle planning with a little bit of CAFE and greenhouse gas compliance kind of sprinkled in there. You know, at the time, the new CAFE, greenhouse gas, and ZEV, the zero emission vehicle regulations, had just been phased in. And it was somewhat important for us to, ensure that regulation compliance was baked into their new products, right? But it wasn't a critical issue since, we have a very efficient lineup. But you fast forward to the present, and you'll find that my job is kind of switched. The roles are reversed. Now, CAFE, greenhouse gas, and ZEV compliance is maybe of the utmost importance. And it's a primary consideration when we're developing any new model or even just revising an existing model. Essentially, every new model that's being developed has to have some degree or level of electrification in order to meet not only the ever-tightening regulations, but also to meet the growing consumer and industry demands for greener transportation. Regarding Hyundai, Hyundai is one of the few companies out there that's developing both battery electric and hydrogen fuel cell solutions for both the light duty and heavy duty markets. I can talk later about why Hyundai believes that both battery electric and hydrogen fuel cell technologies are both complementary, but also essential to ensuring that this country can fully transition towards a zero emission future. For now, I'll just simply say that they're both very important. Regarding hydrogen fuel cell technology, we've been developing our fuel cells for over 20 years. And in the US, we first introduced the Tucson fuel cell back in 2014. And that was followed by the Nexo, which is our dedicated fuel cell SUV that was introduced in 2018 and is available right now in California. Also, we have a heavy duty solution, which is our Exient Class 8 truck, which was introduced in 2020 and is actually available for sale in Europe. And we have about 200 or so Exient trucks running around in Switzerland. And the plans are to increase that to about 1,600 by 2025. And then lastly, here in California, we've actually launched a program with the state of California and the Oakland Port Authority for a dredge program that will see, I think, 30 Exient trucks being put in place in 2023. So thank you again for having me, and now I'll turn it back to you.
Great. Thanks, Gil. Lots of interesting things going on there at Hyundai. Look forward to chatting about them here soon. Next up, we have Dr. Tim Lewin, who is the Executive Director of the Strategic Energy Institute at the Georgia Institute of Technology. Tim, if you want to go ahead and introduce yourself and Georgia Tech and what you're doing there.
Yeah, thank you. So actually Tim Lewin, and I wear actually two hats at Georgia Tech. One is I'm a researcher, and I have actually worked with EPRI for about 2 decades on hydrogen issues. And so as a researcher, I've done a lot of work on basically utilization of hydrogen, whether it's in a water heater or some sort of industrial process or in a gas turbine, working on issues around emissions and operability and things like that. So that's one hat I wear at Georgia Tech. The other hat is the one Joe mentioned, that I run our Energy Institute. So at Georgia Tech, we have about 1,000 people doing energy R&D across the whole value chain. It's a pretty broad portfolio, working with many of the companies that are here, the federal government and states, and a very significant hydrogen portfolio, both on the production side, electrolysis and thermal, and on the logistics and supply chain. We have a major supply chain institute at Georgia Tech, and then also on the utilization side, whether that's a fuel cell or a gas turbine. The other hat I would just emphasize is I've really appreciated the partnership that I've had with EPRI, working with people like Rob Steele and Bobby Noble, working on hydrogen issues for the fleet. And I think there's what's happening with these hydrogen hubs just at this intersection of national labs, government, industry organizations like EPRI, and universities. I think there's a real opportunity for us to really move the needle. So thank you for the opportunity.
Great. Thanks, Tim. And yeah, appreciate your support over the years. Last but not least, we've got Nick Connell, who's the Policy Director at the Green Hydrogen Coalition. Nick, please go ahead.
Perfect. Thank you, Joe, and thank you, EPRI, for including me today on the webinar. As Joe noted, I'm Nick Connell. I'm the Policy Director for the Green Hydrogen Coalition. The Green Hydrogen Coalition is a 501c3 educational nonprofit. Our mission is to facilitate policies and practices to advance the production and use of green hydrogen in all sectors. Through the Green Hydrogen Coalition, we currently have 2 different initiatives. The first initiative, which I lead, is called the Western Green Hydrogen Initiative. This includes 11 Western states, 2 Canadian provinces, as well as 3 other additional states, such as Louisiana, Florida, and Ohio. What the Green Hydrogen Initiative is, it's a public and private partnership to advance and accelerate deployment of green hydrogen infrastructure in the Western region. Our second initiative, which I will touch on quite a bit today, is called HyDeal North America. So HyDeal North America is a platform to launch green hydrogen ecosystems across North America. Each regional initiative will be built around a diverse set of stakeholders, including multi-sectoral off-takers, with the goal of launching scaled supply chains that deliver low-cost hydrogen delivered. And what I will be talking about specifically is our first platform, which is here where I'm located, is Ideal Los Angeles, which aims to create the first scaled ecosystem for green hydrogen in North America, targeting under $2 per kilogram delivered in the Los Angeles basin. So thank you again, Joe, and I'll hand it back to you.
Thanks so much. And yeah, I look forward to hearing more about Ideal LA and Ideal North America here soon. So thank you again to each of our panelists for joining us here. I have a series of questions that I'm going to go through and ask our panelists to respond to. As Kathy highlighted at the beginning of the meeting, if you in the audience have any questions, please do put them in chat. I think maybe something got mentioned about speaking up, but I don't know that we're going to open the lines for anyone to ask questions over the air. So if you do have questions, please put them into chat and we'll get to them as we go through the conversation here. So with that said, I'll start off with you, Linda, and really looking at, the heavy industrial sector, things like oil refining, chemicals, fertilizer, which you highlighted is a big part of what you are working on and you feed into, steel making, cement. Each of these has been billed as sort of a hard to abate sector of the economy. So what role do you see clean hydrogen playing in decarbonizing these sectors? And again, specifically, you've mentioned ammonia and fertilizer, so very interested in your perspectives there. And then for regions with heavy industries present, with hydrogen production methods, which hydrogen production methods are most feasible? And, these are areas like the Gulf Coast, maybe California, the Midwest. About 10 million metric tons of hydrogen is produced in the US today, which is largely in the US, largely in the Gulf Coast for industrial processes. How do you see that amount and that demand changing over time? And where do you see sort of the key areas of growth within that sector? So a lot there, but I'll turn it over to you to start or respond to some of that.
Yeah, we could take the rest of the hour, but we won't. So, for hard to abate sectors, and you named them, right? I mean, steel, cement, ammonia, oil refining, that are already emissions intensive. Many of them are trade exposed as well. Hydrogen is really going to be, and clean hydrogen is absolutely going to be a key pathway to decarbonize. For ammonia, right, it's our feedstock. And so clean hydrogen is absolutely essential to the decarbonization of the ammonia sector. For steel production, where they have to reduce iron and cement, they're not using hydrogen today, but if they have that as an opportunity, there's a really great opportunity for them to really get at the significant portions of emissions in those hard-to-abate processes. So let me talk about what we do to produce ammonia today, right? So we take natural gas and with the Haber-Bosch process, and we make that into hydrogen, and that's where a lot of those emissions occur. And then we bring nitrogen from air and fix it, and that's when we create the ammonia. It is an emissions-intensive process. Most of the world's ammonia is produced using natural gas. Some in China is using coal, which is much more emissions intensive. There's hundreds of millions of dollars we expend every year to be very efficient in our production, and believe that we and Canada and Western Europe are probably among the least carbon intensive ammonia producers today. But we've got to do a lot more to get rid of a very significant emissions profile. So we at CF are looking at the two main pathways, what we call blue and green ammonia production. Blue is using carbon capture and sequestration, where we produce the ammonia the same way we do today. We in ammonia production actually collect a significant portion of those emissions. Some of it goes into another type of fertilizer, granulated urea, but otherwise would be emitted. If we can collect those emissions, compress them, dehydrate them, and then put them into geologic sequestration, we believe that we can eliminate a huge portion of the emissions from ammonia production. We've already announced 2 projects at our Louisiana and Mississippi facilities where we could produce about 1.7 million tons of clean ammonia through the use of carbon capture and sequestration. We also just announced with Mitsui plans to look at a blue ammonia production site in the Gulf Coast, which was going to get to some of the other parts of your questions, as a way to provide some opportunities for Japan, which is looking at ammonia for power generation to replace coal in the early days. But there's issues with carbon capture. We've got permitting, we've got the cost, the investment that needs to be made, and of course we need the permitting and the access to safe and secure geologic sequestration. So we're also looking at green ammonia production. We're doing this at our Donaldsonville facility, where we are putting in electrolyzers, and we'll use water to create that hydrogen and then bring it into our ammonia synthesis loop to make green ammonia. The issues there are electricity issues. So we need abundant, affordable, reliable electricity. And as the United States moves forward on its clean electricity goals, this is really going to be an area where we ramp up. So I think what we see is, in the short to medium term, the easiest, fastest, and most impactful way to reduce and eliminate emissions on ammonia today is going to be through carbon capture and sequestration. And as that electricity comes online and those prices get lower, that's when you're going to see more of that shift into the green ammonia production. And as I said, we're trying to do both because we just can't predict how fast some of this technology is going to develop, how quickly the United States electricity sector is going to be able to decarbonize. But that's really the pathway. A lot of where you see heavy industry today, and certainly ammonia production, a lot of it's in Louisiana, Oklahoma, the Gulf Coast area. And so I think some of the early movement on clean hydrogen for ammonia really could benefit in those areas. There's steel production across the river from us in Louisiana. There's other chemical producers in that area as well. And so I think as we're looking at this hub model, there's a lot of opportunity to produce more or to decarbonize the hydrogen, produce more of it, and supply it to other industries right around those regions. So let me stop there. You've got a lot of other questions, I know, but hopefully that gives you some of your answers.
No, that was great. Thanks, Linda. I know I fed you a lot there, and very interesting, and great that you're pursuing both solutions. I think that's something that we have emphasized quite a bit when we're looking at how to decarbonize these industries, is that we need a lot of optionality. And so there's going to be different solutions for different areas of the country and different areas of the globe. And so great to hear that you're working on a lot of them. Turn to you. You mentioned in your introductory remarks how Hyundai is one of the maybe the only or one of the few companies that is looking at commercial deployment of both batteries and hydrogen powered fuel cells for mobility solutions. How do you look at these two solutions as complementary today and in reducing emission? Do you look at these two solutions as complementary in reducing emissions from the transportation sector? And sort of what are the benefits of fuel cell electric vehicles, maybe relative to battery solutions, or in addition to battery solutions, and what are they? Why are they required to reach net zero in this sector?
Sure. Okay. Yeah, that's a very interesting question. So let me tackle that from a light duty and then from a heavy duty perspective separately. So on the light duty front, battery electrics may indeed be the ideal solution for a majority of consumers. I think that's well understood. It's those consumers who have a place to charge at home or at work, or for whom maybe infrequent recharging is compatible with their driving patterns. It's for this reason that Hyundai actually has a number of battery electric vehicles out there, and we actually will have about 9 battery electric and plug-in hybrid vehicles by 2025. But at the same time, you can't overlook the fact that many consumers simply don't have a dedicated place to charge at home, either because they live in that multifamily dwelling, or in a high rise, or perhaps they park on the street or in a parking lot without dedicated spots. For those consumers, charging is not a convenient option. Now, of course, there's level 2 charging. That unfortunately may not be a realistic option for many of these consumers, perhaps because they can't leave their car at one of these spots for hours on end. DC fast charging, that could be a solution, but we know that it's not readily available. And even when it is, I mean, for some consumers, it still takes upwards of 30 minutes to get a full charge, and that may not be possible for many people. So light duty hydrogen fuel cell, really what it does is it essentially helps those consumers who benefit from the current fueling model, right? I.e., you go to a station, you fuel in 5 minutes, and then you're on your way. There's no need to change your driving behavior or ownership behavior. And we do think that there are many consumers, even as we fully transition to electric, that who will need that type of fueling pattern, right, to be able to own a vehicle. So if you really want to convert 100% of the consumers, then you really need both solutions. Now, on the heavy duty side, it's really about understanding the duty cycles of the vehicles. Battery electric solutions may make more sense, right, for vehicles that are they have predetermined duty cycles below the all-electric driving range. These are vehicles that may not drive long distances, or vehicles that make frequent stops and where you have an opportunity to recharge during those stops. So you can certainly maybe extend that driving range for a heavy-duty electric vehicle, but then that comes at the expense of vehicle weight and then reduced payload capacity, et cetera, et cetera. Now, on the other hand, hydrogen fuel cell is more effective, let's say, on vehicles and applications that have a high duty cycle, where maybe the daily driving distance is longer than the electric range, or where there are multiple shifts, and there's a very limited downtime. So you don't have that much time to be able to recharge. However, you can refuel, a heavy duty fuel cell vehicle in minutes, right? So hydrogen fuel cell may also be the better solution when a fleet requires maybe a large number of DC fast chargers. However, there may be limited real estate, or maybe the on-site electrical infrastructure may not be able to support that many or that high electrical loads, or maybe just the electrical demand charges are too expensive. So obviously there are scenarios for where one technology is better suited, but clearly there are scenarios where the other technology is also better suited. And then one additional thing that I think is very important, maybe not is kind of overlooked, is that light duty and heavy duty fuel cell vehicles, they actually complement each other. So a light duty can provide the scale, right, that can help lower the fuel cell component costs, right, because there's going to be a lot more light duty vehicles than there are heavy duty. Our Exient heavy duty truck, it actually essentially uses 2 fuel cell stacks out of our light duty Nexo. So unlike conventional vehicles where you have a big heavy diesel engine that has nothing to do or not related at all with a light duty, gasoline engine, for fuel cell, the heavy duty and the light duty stacks are actually interchangeable. They're very similar. On the other hand, heavy duty provides the increased fuel demand, right, that can help lower the fuel cost of hydrogen. So the Exient can easily consume well over 70 kilograms of hydrogen fuel in a day, depending on how you're driving it. The Nexo will probably less than 5 kilograms of hydrogen a day if you're driving long distances. So again, heavy duty can reduce the fuel costs, light duty can help reduce the component costs. So they're quite complementary in that way as well.
Great. Thanks, Gil. I mean, it sounds like, once again, optionality is sort of the name of the game. But also, I think one of the things that I heard from you there is an important measure to consider is just the systems level perspective when these things come together. It's not just one solution and then try and move that forward, but it's really a systems approach that's needed. Dr. Lewin, turning to you and turning to sort of the power sector here for a bit. Hydrogen's emerged as a strong potential sort of zero carbon power generation fuel. It can be used in gas turbines or fuel cells and can provide baseload power if that's what's needed, or flexible resource if that's what's needed to fill in the gaps for intermittent renewables like solar and wind. Turbine manufacturers, they're currently testing capability of current technologies to either blend hydrogen and natural gas together, or potentially go as far as they can really with hydrogen in that blend, as well as developing 100% hydrogen fueled turbines. Could you maybe briefly address the benefits of natural gas and hydrogen blends and why they're sort of a useful maybe first case for utilizing hydrogen in the power sector? And then also talk about pure hydrogen powered turbines and what they could do in achieving a deeply decarbonized electric grid, sort of what are the best, and to that maybe add what are the best use cases for turbines and or fuel cells relative to one another, or maybe just their use case more generally in the power sector.
Yeah, thanks, Joe. That was I'll see if I can remember all those points. But I think maybe just to tee this up, I think, first of all, I think for this audience, it's very clear, but I just want to emphasize that for the purposes of my discussion, hydrogen is not a source of energy, right? You basically, if you have utilized some means of making hydrogen. And then in essence, what hydrogen is it's a big energy storage medium. It's like a big battery. And if you're sticking it in the natural gas pipeline, you have a massive battery. And then the question becomes, how do you best convert that energy that is in that hydrogen back into some useful form, which could be electricity, it could be heat, it could be cold air, and so forth. And that's really kind of what the angle is. And so if you think about, today there's probably, there's two major means for converting hydrogen back into something useful. Gil already mentioned one, which is fuel cells, which has a very important transportation use case, but fuel cells also have a really important use case on electric power generation. These devices are in many cases or were originally designed around hydrogen, so there's no conceptual challenge with utilizing hydrogen on them. And in fact, there's some of the most advanced fuel cell concepts out there, which are not commercial today, are in fact hybridized versions where you actually take a fuel cell and you combine it with a gas turbine or a reciprocating engine, and that's going to give you the highest efficiency of converting that latent energy into useful power of all. But where, in general, it's a matter of scale, right? I mean, gas turbines tend to always win as you go bigger. Smaller scale applications will oftentimes move towards more fuel cell type applications. And so, the beauty of a gas turbine, so I'll make some comments now about gas turbines, is that they are very fuel flexible. They're not designed around a fuel, or there's nothing intrinsic about the way they work that is specific to a fuel. Just think we've got a lot of airplanes today that are flying on Jet A, which couldn't look any more different from methane or hydrogen. You have, military aircraft flying on all kinds of really interesting concoctions. Gas turbines have been run on ammonia. Commercially, not commercially, but in large scale tests, even back in the late 60s. And so there's nothing intrinsic about it. There's no fundamental technical issue with running a gas turbine on a hydrogen, whether it's pure hydrogen, pure methane, or any blend in between there. But where the rubber kind of hits the road from both a business case as well as a technology realizability point of view is when you want that same turbine to be able to operate with a range of fuel compositions, for it to be fuel flexible. So in other words, if you want the system to be able to operate with pure natural gas and pure hydrogen and be ultra low emissions, that's kind of where that's the kind of the cutting edge of R&D today. It's possible, but it requires a change out in your technologies. But I mean, again, pretty much the entire gas turbine fleet out there today can handle some limited amount of hydrogen. Might be, let's just say 5%. I'll just throw that number out there. That's today. There's a lot of really nice technologies which are already being sold, which can handle 20, 30%. And every OEM has developed technologies to handle 100% hydrogen. And so then it's just a matter of what's the range of compositions that you would expect that use case to see, and what is the emissions permit. So, and again, I will emphasize there are gas turbines running today around the world that are running on essentially pure hydrogen. They're just older technologies that don't have the same emissions requirements that new technologies do. So I think I'll stop there.
Well, great. Yeah, I mean, it sounds like, a lot of work's been done. We have maybe some of the technologies we need there, but it's more proofing and really operating these systems to drive them forward and truly understand maybe the small operational intricacies that we need to understand on hydrogen relative to some of these more traditional fuels, with the note that you have highlighted that we do operate some currently already on hydrogen today. Linda, I think you also wanted to offer some comment maybe specifically around ammonia and its operation in the power sector, or potential for operation in the power sector.
Well, exactly along those same lines and looking for new uses, one of the things that we're seeing in Japan in their power sector, where they are very significantly coal-based, and the government is very ambitious in terms of its carbon elimination goals. JERA, their major power company, is looking at trialing the co-firing of ammonia for power generation, obviously decarbonized ammonia to get there, and working on some of the technical aspects that we've been discussing here. But it's just it just gives you a sense of how as we try to grapple with these new challenges, we're trying to find some new opportunities there as well, and using the engineering and the science to get us there.
Yeah, and I mean, we've been working closely with some of our Japanese stakeholders as well, and I guess it just goes to emphasize again the need for optionality for folks across the globe that are in different situations, given the different resources they have, and the ability again that we need to enable to have looking at a variety of options that are going to meet those needs. So Nick, I'm going to turn to you. You're sort of bringing all of this together. With HyDLA. It's an ambitious initiative that's going to reduce the cost of green hydrogen to $2 a kilogram in the Los Angeles basin. Obviously addressing the cost of decarbonized hydrogen is going to be key to deploying clean hydrogen across multiple end uses like we've discussed here already. Will achieving this $2 a kilogram cost target drive demand for hydrogen end uses? And once this cost target is achieved, what are some of the applications, maybe the initial applications and then the long-term applications that you see for clean hydrogen?
Yeah, Joe, short answer, absolutely. I do believe that, sub $2 per kilogram delivered will drive use and end use within the LA basin as well as throughout California. So just the context set, so HyDeal Los Angeles, we wrapped up phase 1 of our scope in the end of last year, so around September. Within the phase 1 scope, what we did was we identified multi-sectoral off-takers in the LA basin. We're prioritizing areas with the highest pollution near the ports of LA and Long Beach. This includes our power plant production, as well as the refineries, as well as the ports. So what we want to do is to determine where the mass-scale green hydrogen could be produced from water and renewable electricity via electrolysis. While there's other ways to produce the green hydrogen, say through biomass or biogas, we focus primarily on electrolysis because of the uniqueness of California with our wind and solar resources. In addition to that, we evaluated the alternative transport and storage solutions for the lowest cost alternatives. And so why $2 per kilogram? We found that the delivered price for mass-scale solutions make the most economic sense. So in this exercise, we interviewed large potential off-takers, and we learned that cost was the missing link. So to put this in perspective, Phoenix Marine Services, which is the second largest terminal operator in the Port of Los Angeles and Long Beach, they're already electrifying as much as they can. They're working on electrification. They have a goal by 2030 for the Port of Los Angeles to be 100% renewable. However, unfortunately, they have more than 350 discrete diesel fueled engines that cannot be fully electrified because of their duty cycle, which Gil was pointing to earlier. And to put this in perspective, they consume about 150 or 175,000 gallons of diesel per month. In conversations with them, they said, yeah, we could upgrade these diesel engines to fuel cells, but the only thing stopping progress is cost. Their break-even costs for green hydrogen in the basin would be sub $3 per kilogram. So making this decision for them would be a no-brainer if we could get that cost there. So that's just one aspect of it. So that's just looking at the ports. On the power production side, Los Angeles Department of Water and Power, with their thought leadership, they're already working on this today. By 2030 to 2035, they want to have 100% renewable green hydrogen power plants in basin. To achieve this, the most cost-effective way to do it is to have a dedicated pipeline paired with some kind of geologic salt formation. Through phase 1, we did analysis. We looked at the geologic salt formations in Utah, as well as potential ones in Nevada. And through that analysis, we found that we'd get it down to sub $1.95 per kilogram delivered. So when you ask about the end uses in California, I think it spans a variety of ways. You know, transportation is one huge application, medium, heavy duty. That makes complete sense, as well as industrial, refineries, decarbonizing those, eventually producing ammonia for fertilizer, for agriculture, but also the power sector. We're looking at the need for firm, clean power. And how do we achieve that? In California, the SB 100 analysis found that we need 15 gigawatts worth of firm, clean power by 2045. The only sources that are viable to do that, well, not the only, but one of the biggest potentials would be green hydrogen. So looking at long-term gas planning, there will be a future to where we need that firm power, as Tim pointed out, for long duration storage. It's going to be a need. We're going to have more intermittency with more renewables on the grid. So I'll hand it back to you. I know it's a mouthful, but a lot going on.
No, yeah, no, that's great, Nick. And I think it was interesting you highlighted there too the cost of transportation and storage, and one of the things you're considering there. And so I know DOE has a dollar per kilogram target out there for hydrogen, but that's just for production. So this $2 per kilogram, including transportation, is really aggressive, and it's great to hear that you guys are working towards that. Linda, I'm going to turn back to you and appreciate, we've only got a little bit of time left with you. Appreciate you dancing between your board meeting here and joining us. But CF Industries, we already talked about sort of, you're looking at blue and green ammonia, but you do have an announced project in Louisiana to produce 20,000 tons of green ammonia that's supposed to come online by 2023 here. Could you talk a little bit about that project, what you see the ammonia being used for out of that project, and why the green ammonia is particularly attractive to maybe some of those in-use applications, and how that effort is going to enable Louisiana to build out some regional hydrogen hubs, potentially with DOE's help there?
Great, thank you, and apologies in advance when I disappear to everyone. This has been a great discussion so far, and I've learned a lot. So yes, we've got a 20 megawatt green ammonia facility being developed in our Donaldsonville, Louisiana facility. It's only producing about 20,000 tons per year, which in our overall ammonia production of about 10 million is not a lot. But what this project is going to give us the opportunity to do is to really learn how to integrate these electrolyzers, the electricity, all of that, and make sure that we understand how to move this forward as electrolyzer technology changes, right? That's a piece of it. As electricity prices, as that renewable power is available, and those prices are priced accordingly. And, we really see this as just the beginning. We know there's, depending on where one is located and hydroelectric power or other power sources, that green ammonia is going to be a product in strong demand. Obviously, if it were priced higher, then the cost to make it, that changes the economics. But today, I think, there's a lot of interest, and I was just discussing with someone in the chat, in shipping, there's the potential for ammonia being used. I mentioned the power generation. And at this point, it's not clear whether it's going to be green or blue. But I think as we look along that 2050 trajectory, what you're going to see is a changing mix, and over time, that green production is definitely going to ramp up and be increasingly expected here. I think it's a great opportunity to showcase how all of this works within an existing manufacturing facility within one of these Gulf Coast states where we have these opportunities, where we have the power, where we have the water, as well as the demand for that final product going forward. So we're excited by this, and yes, it's due to be complete by 2022, yeah. And so we are very excited to see how this goes forward and to see what next projects we might be able to announce.
Well, Great, thanks, Linda. No, it's exciting times getting started. You got to start somewhere, and so 20,000 tons is maybe small in the grand scheme of things, but it's a good start, and look forward to hearing more about that project. And appreciate you joining us. No, you do have to run here soon. Gil, gonna turn back to you. You talked about your Hyundai's Nexo passenger offering, in California, additional offerings that may be coming down the pipeline here. Obviously, to have a viable transportation offering, whether it's light duty or medium duty, you have to have a supportive hydrogen refueling network. What lessons do you think you've learned from Hyundai's experience in California that it can be applied to scale up of fuel cell vehicles maybe across the country? And how do you think that the DOE Hydrogen Hubs effort can accelerate fuel cell EV or fuel cell electric vehicle deployment more broadly?
Okay. Yeah, so I think it's important, maybe this is very obvious, but unlike battery electrics, which you can actually sell without having any public infrastructure, right? Because you can rely at least initially on home charging and those consumers who can charge at home. Hydrogen fuel cell electric vehicles cannot be sold at all without fueling infrastructure. Fueling infrastructure is critical to the deployment of any hydrogen fuel cell vehicle, be it light duty or heavy duty. And rolling out vehicles is impossible, right, without available, reliable stations, but also resilient fueling infrastructure. So when we introduced the Tucson fuel cell in Southern California back in 2014, I believe there were around 4 or 5 hydrogen fueling stations in all of Southern California. These stations had limited fueling capacity and experienced frequent downtime. Now, fast forward to current day, and we actually have, I think, a little bit over 50 public retail hydrogen fueling stations in California. And some of these stations actually have over 1,000 kilograms of hydrogen fueling capacity per day. Now, these stations have become much more reliable, and customers are experiencing a much better situation. But at the same time, they still experience stations that go down from time to time, as well as the network actually running out of hydrogen fuel from time to time. So, with those findings, what we've learned is that from a light duty private consumer perspective, if you're going into a new state or a new region, you can't simply rely on having 1 or 2 stations. That simply doesn't provide the sufficient amount of redundancy necessary to ensure that customers have a satisfactory fueling experience and ownership experience. Instead, what we find is you really need to have kind of a small network of stations in place, right? At the same time as you're introducing a light duty vehicle, fuel cell vehicle in the new area. Now, for a heavy duty fleet customer, it might be a little bit different, especially if that fleet customer uses more of a hub and spoke type of model. So there you could have a centralized fueling location, right? One only, and that may be sufficient. And in some ways, maybe that's a better way or an easier way of launching into a new market. In addition to that, there are other findings. So one thing is that it's extremely important to identify the correct station locations from a light duty perspective. And this is an area that we work closely with station developers on. You have to make sure that the station is located in an area where you're going to find early adopters and consumers who are more likely to purchase or lease a fuel cell electric vehicle. Also engaging early on with the local jurisdictions is very important, because what you find is very few of them have any knowledge, working knowledge or experience dealing with hydrogen as a fuel. And so there's a lot of concerns and issues and misconceptions associated with that. And so the earlier you can engage with them and educate them, I think the better, especially as it comes time to be able to develop and certify a station in the different areas. And every area is going to be different, right? I think in California, the local jurisdictions now have much more experience and exposure to hydrogen. The station development process is a lot easier, but I think as soon as you go into another state, another area, it's like you're starting from scratch. So there's a lot of learnings that can be taken there. And I will say, for those who are interested in something like that, then I would say that you should visit like the California Fuel Cell Partnership. They actually have a lot of data and information and background and research done into that area. Now, regarding the hydrogen hubs, the DOE program, so they actually represent a fantastic opportunity to lower the cost of low carbon hydrogen, as well as an opportunity to develop, I think, infrastructure to distribute and dispense hydrogen, especially in areas that really don't have the same market incentives that California does. So we are seeing, I think, a lot of states kind of very interested in this. I think the Northeast, there's some in the South, mountain states as well. So I think we're hoping that this is maybe the launch of an expansion of hydrogen outside of California.
Great, thanks, Gil. Yeah, I mean, it's interesting. We so often in this space talk about the chicken and egg problem with supply and demand, but maybe the real challenge is that neither will survive unless you have the right environment for them to grow and thrive in. So infrastructure is obviously going to be very key in enabling both supply and demand. Dr. Lewin, I wanted to turn to you one last time here. So a lot of recent media coverage has raised questions around pollutants from hydrogen combustion. And I think we even had a question in the chat that was talking about N2O. But one of the pollutants that gets brought up more often is NOx or NOx emissions, whether that's NO2 or NO3. Either N2O or NOx emissions, how will the next generation of turbines reduce these emissions overall? And specifically for hydrogen, can it be a low or no NOx power solution so that we don't address one problem in CO2 and create or worsen another problem with low-level pollutants?
Yeah, so I'll start with the short answer is that there's no fundamental reason that we can't utilize hydrogen and generate very, very low levels of NO. So I'll start out there and now I'll give a more detailed answer. And I think for those of you who aren't used to thinking about regulated air quality pollutants, it's important to recognize is that there's the stuff that we emit that causes climate change, like carbon dioxide, and then there's the stuff that we emit that's regulated by the EPA that causes air quality issues like smog, things that lead to smog like soot and sulfur containing compounds, things that give us acid rain, things that cause respiratory damage and things like that. And so some of those pollutants come from the fuel itself. So for example, sulfur, if you have sulfur in your fuel or if you have carbon in your fuel, you can make things like soot or different types of sulfur dioxides and things like that. So when you use a clean fuel like hydrogen, those go away. However, one major source of NOx potentially, which leads to acid rain, just comes from good old-fashioned clean air. If you take clean air, not to make this a chemistry class, but it's composed of nitrogens and oxygens. When you heat up nitrogen and oxygen above a certain temperature, they start to react and you get NO. So anything that you do that gets air above some magic temperature, which is about 1800 Kelvin, you'll start to form NO. So hydrogen combustion, if not done correctly, can give you elevated levels of NO. And so this is where, so the media attention and some environmental groups have been looking at this and saying, well, hold on, do we really want this hydrogen economy? And what's been happening is they've been looking at some data sets, and frankly, they're flawed data. They're flawed data, and they're for this reason, is that if you look at older utilization technologies, they're high NOx technologies. And so if you put hydrogen into an older gas turbine, you will get a lot of NOx. Just like if you take a brand spanking green biofuel and you put it in your grandpa's 1940s tractor, it's going to make soot. Sorry. However, if you take hydrogen and you utilize it in sort of modern, what we call DLN, dry low NOx combustion technologies, you can make very, very low NOx levels. So the last thing I would just say is about ammonia. There was a question about ammonia emissions. Ammonia is a much harder issue for NOx mitigation because the nitrogen is embedded in the ammonia. And so if you burn pure ammonia, even in the sort of the best in class type combustion technologies, you're going to make a lot of NOx. And so the only way to really deal with that is through post-gas cleanup. So really, if we're talking about trying to get to NOx levels, which we're used to seeing today with sort of ultra clean natural gas systems, you're either going to have to take your ammonia and crack it, basically run Haber-Bosch backwards, turn it back into N2s and H2s, which is one way, or you'll need a pretty significant exhaust gas cleanup system.
Great, thanks. And I know with the work that we're doing at EPRI and doing in partnership with you, NOx emissions is something that I think we both believe can be addressed, but also strongly believe that we need to address it so that we don't create a second problem. So looking forward to that continued effort with your team there at Georgia Tech. Final question that we have prepared, and hopefully we'll have some time to at least gather some of the questions that I see here in chat. Nick, for you, Los Angeles is a leading manufacturing center in the United States. It's obviously the hub or the home of the ports of Los Angeles and Long Beach, two of the busiest ports in the world that have gotten a lot of attention here recently with some of the supply chain crises we've had. Could Ideal LA and the DOE Hubs program serve as sort of a jumping off point for California to become a cross-sectional regional hydrogen hub, serving, again, a multitude of end uses? We've talked about transportation, we've talked about power generation. We haven't talked about maritime so much, but that obviously would be very important for the ports. And based upon your initial findings from Ideal, what do you think are some of the major policy and or market development barriers that need to be addressed to allow us to make near-term and long-term progress in moving hydrogen forward in these various sectors?
Yeah, Joe, thank you very much. I 100% do believe that this will be a jumping off point between the efforts at Ideal Los Angeles, the efforts through Los Angeles's leadership through LADWP, as well as the mayor's office, and the additional support from the H2 hubs. I believe California is positioned in a place, especially on the 4 different hubs, one of them being renewable, and us having an abundant amount of renewables, as well as a lot of the analysis that has gone into hub development in LA positions us really well for that. And you know, California being a larger state, I mean, we have other hubs that are popping up as we're talking about, and Gil pointed to that. It's like, I feel like every other day you see an article with a new hub. So we'll probably have what I like to call a hub and spoke technique to create a national backbone. But through Ideal, I think the biggest, most critical in the near term is moving away from the colors of hydrogen and looking more at the carbon intensity framework and using that carbon intensity framework from a national perspective. We're talking about this regionally now, but when we start doing interstate transactions, so if I'm selling hydrogen produced in Utah down to California or Nevada, we need to be speaking apples to apples. So what is the carbon intensity? And once we get that carbon intensity framework in place, and that's going to include a life cycle assessment, how are we assessing? Are we assessing it from a well to gate, a well to wheels, different assessments? But if we could come to a common methodology, we could really start scaling this beyond intrastate and moving to interstate. And that's going to be huge. Once we could figure out that carbon intensity framework, we could develop a certification and tracking framework, similar to the way that our renewable energy certificates are done today. And then we could start putting premiums on the cost of hydrogen and how clean that hydrogen is compared to others, which will create a market. And once that market's developed in the long term, it's going to be pretty competitive, especially with decarbonization goals popping up, I think, more than hubs right now through legislation. So I'll leave you with that. And I did have one note to Tim's comments, especially about the NOx emissions. One thing I think is interesting, too, that we're seeing in Los Angeles is the usage of using these power plants for reliability. While these power plants, and the concerns of NOx, but they're going to be used on very small basis. They're going to be used for reliability events, just like a storage device. So NREL study, their NREL 100 study, to get us to that point, I recommend everyone checking it out. They have an environmental justice component there that shows that the way that these turbines are going to be used in the future, it actually reduces the NOx to 70 to 90% based on usage. So when we look at use cases into the future, we have to keep that in mind as well, especially with new technologies coming on board. I think that, once we get more data out there, and then a lot of the manufacturers that are coming up with these new innovative technologies, we'll be able to solve those issues. So just wanted to jump on that, but I appreciate the time, Joe. Thank you.
Very much. Great, Nick, and appreciate your comments there and following up on the NOx question with your perspectives as well. So we have 3 minutes left in our discussion today. So I think that leaves me time to maybe grab one question, and I'm gonna grab one of the one of the ones that at least each of our panelists can spend a little bit of time speaking to. There's a lot of great questions in the chat, but a lot of them are maybe much more focused on one particular panelist and their response. So I'm gonna grab this question, and we talked a little bit about it when we were talking about the $2 per kilogram goal that Ideal LA has. but the DOE goal for the hydrogen shot that they've announced is $1 per kilogram in a decade. That's production, so that doesn't include transportation or any of the concerns there. But the question is really, what are the thoughts on the feasibility of achieving that target? And maybe I'll add in, is that target low enough? And I'll just go through the three panelists that we have left on the line here. So maybe Gil, I'll start with you. Any perspectives on the DOE hydrogen shot target and whether it's good enough?
It certainly is a very ambitious target, and it's one that I think a lot of fuel providers are definitely working on and trying to achieve. From our perspective, so right now, hydrogen fuel for consumers is significantly more or higher than gasoline. And so as a result of that, we actually do provide fuel cards to our owners where we provide free hydrogen fuel with the purchase or lease with Nexo. But essentially what we need to see is hydrogen prices reach parity with gasoline, and then ideally below gasoline prices in order to engage or encourage consumers to start looking at this technology more seriously. Recently, with the increase in gasoline prices, actually price parity was very close to being achieved. So I think certainly if we can achieve something like $1 for production cost, that would put hydrogen in a very good spot in terms of fuel costs for consumers.
Dr. Lewin, same question to you. Quickly here, any thoughts on the hydrogen?
So I think the only thing I would say is that, you know, without CO2 regs, you know, if hydrogen, if let's say if green hydrogen is competing with natural gas, it's probably not enough. Although, you know, we'll see what happens to natural gas prices. The other thing I would just point out is that the way the U.S. market prices energy for something that's a gas versus a fuel that's a liquid very differently. You're going to pay about 4 or 5 times as much on an energy basis for something that wants to be a liquid, like gasoline or Jet A, as opposed to something like natural gas, simply because energy is so cheap in the U.S.
Great. And last but not least, Nick, your thoughts in about 30 seconds or so.
Yeah, I'll keep it less than that. I would say, yeah, it's achievable. I think it's more a market development and market design question. If we could drive production and get large scale production, so like a PTC through the Build Back Better, something like that to where we get more projects in the ground, I think with scale it's feasible. Thank you, Joe.
Well, great. I want to again thank the audience for your attention. We have a number of questions in the chat here that I think we'll collect and do our best to have some response to. I want to thank our panelists again. Really appreciate you guys taking the time to chat with us and about the Hydrogen Hub solicitation and more general the opportunities that are coming out here. And again, just as a reminder to everyone, this session has been recorded along with our previous session, so you will receive an email after this session is over with details on how you can access those recordings. Kathy, I don't know if there's anything left that needs to be said. I'll turn it over to you maybe to close us out.
No, we appreciate everybody being here today. Jeff or Will, either one of you would like to say anything, jump in here, but I appreciate you taking charge, Joe. Great job, everyone.
Thanks, everyone. Great discussion today. Really appreciate the time.